Alright, we have a cheerleader lifts his 69.8 kilogram partner, so we're given mass, straight up off the ground, a distance of 0.69 meters, so that is my height before releasing her. So releasing her as in letting her go, letting her fall, not setting her back down. So that'll come important later on. So the wording here is important. Assume the partner's velocity is 0 at the beginning and 0 at the end of the lift. Okay, so that's another important part or piece of information. We are 0 at the beginning and end. And what that means is that the kinetic energy originally and the kinetic energy at the end, the final, those are both equal to 0. So we're not worried about kinetic energy at all. And then it tells us that gravity is 9.8, and he does this a total of 22 times. So the question being asked is how much work has been done. So we know work is force times distance, and we could do that equation, or we can do work is equal to a change in energy. And I prefer using that version because it's pretty easy to tell that if you're lifting somebody up, the energy that's changing is their gravitational potential energy. So it's potential energy of the gravitational flavor. And what that means is that work is just going to be equal to the equation for potential energy, which we know is mass times gravity times a change in height. That's the only variable that's really changing at all. So the work that our cheerleader does on one lift would be equal to the mass, 69.8, times gravity, which is 9.8, multiplied by the change in height. And they're lifted up 0.769. So if we multiply that out, we will get the work done in one lift, which is equal to 526.0, and that is in joules. Now you would think that that was our final answer, but it's not. That's the work for just one lift. The question is asking us how much work would be done if he does that same lift 22 times. So that is just equal to 22 times the work done for one lift. So the work for 22 of those lifts would be 22 multiplied by 526.0, and that is going to give us a final answer of 11,573 joules. And that is our final answer.